The James-Webb Space Telescope is without a doubt one of the most complex pieces of equipment mankind has ever produced. As the most powerful space telescope of all time, James-Webb is expected to give us an unprecedented insight into the great mysteries of the cosmos in the coming years. But even before the ambitious mission has really gotten rolling, the project is already facing an unexpected complication. The Space Telescope has been hit by a small body. Find out what's behind this collision and what breathtaking insights the very first Webb images give us in today's video. Want to learn more about the groundbreaking discoveries and unique spectacles in the universe on a regular basis? Then remember to subscribe to Simply Space and click the bell to never miss one of our videos again. By giving us a thumbs up, you're motivating us and showing that we can keep you excited with the content of our posts. Collision. Between May 23rd and 25th, an unpleasant incident occurred in the gigantic expanses of space. The James-Webb Space Telescope was hit by a tiny meteorite. Fortunately, the astronomical missile was not large enough to cause serious damage to the equipment or even to destroy it completely. Nevertheless, the impact of the micrometeorite was accompanied by a noticeable effect, which the telescope data revealed. Specifically, one of the primary mirrors was slightly damaged in the incident. NASA staff immediately began to thoroughly analyze the consequences of the impact. In the same breath, the engineers devoted themselves to readjusting the mirror segment that was hit. Anyone who believes that the collision was an unexpected, isolated incident is mistaken. Although Webb did not leave our blue home planet until December 25th, 2021, 5 impacts of this type have already been recorded. In contrast to the most recent incident, however, the previous collisions left no significant traces on the $10 billion piece of equipment. And according to the experts, the latest event is not a cause for concern either. The initial investigations showed that the Space Telescope is still fully operational. Accordingly, nothing stands in the way of the start of scientific operations in a few weeks. In fact, the designers knew in advance of the mission that such incidents could occur from time to time. Collisions with particles the size of dust grains, which chase through space at extreme speeds, are unavoidable. For this reason, Webb designed the 18 mirror segments to be correspondingly stable. In addition to the occasional impact of micrometeorites, the Space Telescope must withstand many other demands of its extreme working environment. These include harsh ultraviolet light, charged solar particles, and cosmic rays originating from exotic sources. Despite the precautions taken in advance of the mission, the recent collision proved larger than those impacts the experts had previously modeled. Micrometeorites can grow to a few millimeters in size. When the tiny projectiles enter Earth's atmosphere, they reach speeds of more than 40 miles per second. Where the microscopic meteorite came from is unknown. However, scientists do not believe its origin was in a meteor shower. Currently, a team of engineers is working out strategies to prevent such disruptive events in the future. Beginning of a new chapter. The future has begun. A few days ago, NASA released the first images from the James-Webb Space Telescope. The fascinating images taken by Webb 900,000 miles from Earth were first transmitted to the Space Telescope Science Institute in Baltimore. The regions and structures captured on image embody nothing less than the dawn of a new chapter in space exploration. The immense expectations that have always accompanied the costly project also exerted a certain pressure on the members of NASA's management team. Which images should be presented first to the interested world public? With the support of PR consultants, the experts agreed on a series of celestial regions that would provide visual proof of the Space Telescope's capabilities. The goal was for the first images to be as colorful as they were diverse and to cover as wide a range as possible of the research areas to which Webb would devote itself in the coming years. The main goal was to reflect the 3 main tasks of the complex instrument: the study of star formation, the analysis of exoplanets, and of course, insight into the early days of the cosmos. As a result, NASA staff settled on 5 images from a pool of 70. The objects first targeted by Webb were subject to absolute secrecy. Even die-hard insiders did not know for a long time which areas the Space Telescope would capture on image. The original plans called for the first images to be released on Tuesday, July 12th. However, US President Joe Biden threw a wrench into the works of this scheduled implementation. The head of state of America instead presented one of the breathtaking images to the interested public a day early, on Monday. Afterwards, it was also time for NASA to lift the cosmic veil, so that we can finally admire the first detailed James Webb images in their full glory. Spectacular insights. Among the most impressive Webb images is undoubtedly the image of the Carina Nebula, located some 6,500 to 10,000 light-years from our blue home planet. The stunning structure embodies one of the largest H2 regions in the Milky Way. These exciting cosmic regions are interstellar clouds of luminous gas in which new stars are born. The Webb image of the Carina Nebula shows us in a stunning way the natural beauty inherent in the structures of the cosmos. The gas and dust clouds seem to form gigantic mountain ranges, and the colorful clouds repeatedly tear small gaps in the nebula, giving us a glimpse into its innermost regions. New celestial bodies are constantly being formed in the gigantic cradle of stars. The gas in the clouds compresses and heats up, allowing hydrogen nuclei to fuse into helium. Of course, Webb was not the first space telescope to image this nebular complex in the Sagittarius arm of the Milky Way. However, the instruments of the past were not capable of seeing through the dense dust envelope. As we know, however, Webb was designed specifically for infrared astronomy, which is why it is able to optically penetrate the star dust and give us entirely new insights into the world of star birth. The view back. Why Joe Biden chose the Webb image of SMACS 0732 for his unscheduled first release was probably because the image literally looks deep. This image looks much further into the distance than the other Webb images, compared to the Hubble images of this region of the sky. Webb also reveals galaxies that were invisible to the working spectrum of the predecessor telescope. Thus, the spherical, shimmering white formations are the components of a large galaxy cluster. For comparison, the distance gaping between us and this galaxy cluster amounts to as much as 4.6 billion light-years. The light comes, therefore, from that time in which our domestic solar system was just born. However, this is nothing in comparison with the galaxy which lies 13.1 billion light-years far away from us. This might be one of the earliest galaxies of all. Altogether, the concentrated galaxy collection brings it on 340 trillion solar masses. Glittering star death. NGC 3132 is classified as a planetary nebula. Contrary to the official name, these nebulae have nothing in common with planets. They are envelopes of gas and plasma ejected by dying stars. This misleading name comes from the fact that the nebulae usually appear spherical in the telescope and visually resemble planets, originally included in the list of Webb's first subjects because of its intense color. The images of NGC 3132 hold some surprises for the experts. The images, taken at different wavelengths, show us how complex and multi-layered the composition of such structures really is. For example, the near-infrared image resembles those already provided to us by Hubble. In the case of the mid-infrared range, however, we see that the two stars at the heart of the nebula appear almost equally bright. The white dwarf that has shed the colorful envelope can be made out in much more detail here. The bluish glow we can see in the outer areas also suggests the presence of hydrocarbons. Cosmic pileup. The Stephens Quintet galaxy group comprises 5 individual galaxies in the constellation Pegasus. Located about 300 million light-years from Earth, the individual spiral arms of the collections of stars exhibit irregular shapes. This optical feature is due to the gravitational effect that the galaxies exert on each other. In fact, this mutual gravity also causes Stephens Quintet to become the scene of galactic pileups again and again. Thus, galaxies steal each other's stars, while tidal forces throw the overall galactic complex into chaos. Moreover, the researchers traced a mysterious structure above the 2 smaller galaxies. A detailed analysis in the X-ray spectrum showed that this is a gigantic shockwave. It appears that the shockwave originated in one of the two small galaxies. As it plunges towards the group center at a breakneck speed of a few million miles per hour, it also heats the intergalactic gas to several million degrees Fahrenheit. Spectrum of WASP 96b. Webb's overall research goals also include the analysis of distant exoplanets. However, it's only in the rarest of cases that it's possible to directly capture on image these alien planets orbiting a host star other than the Sun. Nevertheless, the light from these cosmic worlds can be indirectly analyzed and studied in terms of its spectral composition. The study of spectra not only allows us to detect astronomical formations, it also tells us much about the chemical composition of celestial bodies. The published spectral analysis of exoplanet WASP 96b gives us a taste of all the milestones Webb is soon to reach in this regard. Now it's time for your opinion. What do you think about the exciting deployment of the James-Webb Space Telescope, and which of the images shown fascinated you the most? As always, drop us your thoughts, suggestions, and feedback on today's video in the comments below. Finally, feel free to take a look at the other posts on our channel, which you can access by clicking on one of the images in the credits now. Thanks for your interest, take care, and we'll see you next time.